and vessel. I'm Azlan Abu Bakar. I will moderate the session today, and together with me is Nur Sabrina Jamal Muhammad, who will assist me in moderating the session towards until end of our session today. So before we proceed, let us go into the agenda for our session today. First, uh, I will well, I will share background of the speakers today, which are IR Tong Wenji and Mr. Charles Lim. And then the speaker will share their talk on the specific topic that are highlighted here with regard to the theme that are highlighted just now, talking about floaters or floating structures and vessels. And then we go to second speaker, Charles Lim. Last but not least is photo session. And at the end of the session, we will show you QR code where you can scan the QR code and fill up your email for us to provide you the certificate of attendance. But please bear with us until end of the session for us to share that QR code for your certificate of attendance. Okay, right? And before we start, I just want to share that this session, a technical talk, or we call it a tech talk, is organized by Malaysia Joint Branch Rina Imares, MJB Rina Imares. So uh, without further ado, let us go to see, or let me brief you our first speaker, which is IR Tong Wenji. Allow me to brief a bit on his career and performance background. IR Tong Wenji is an expert in floating structures in oil and gas industry, specialized in the full life cycle of marine and offshore assets, particularly floating structures. His expertise encompasses every phase from initial design through late life operation with a proven track record of delivering successful outcome in complex projects. So key areas of expertise include front-end engineering and design in conceptual studies, pre-FEED and FEED phases, involvement in project execution, particularly in new build, conversion and life extension project, installation and relocation, which are delivering seamless offshore installation and redeployment of assets, integrity management and late life operation, which is ensuring the reliability and sustainability of FPSO, FSO, and semi-FPS assets. His education, talking about his education, IR Tong Wenji have a master of philosophy in marine technology, mechanical engineering, UTM, and then he has his Bachelor of Engineering under Civil at UTP. He he also is a professional engineer with practicing certificate by BEM. At the same time, he also has the ACPE, Asian Chartered Professional Engineer, and he also a chartered engineer MRINA UK. So without further ado, I would like to hand over uh, the screen to IR Tong Wenji to share his topic today. Please welcome IR Tong Wenji. You are muted, Wenji.
Okay, sorry about that. Okay, let me start again. Thank you so much, Jaslan and No Sabrina, the committee of MJB Rina Imares, for organizing this event. So, and also thank you so much to Jaslan for the introduction on my career and also my aspirations. Okay, without further ado, let me take control of the screen and then to present my topic. Okay, so, oh, sorry. Here you go. Okay. Okay, so firstly, I'd like to give a special thanks to the MJB Malaysia Joint Branch, Rina and Imares, for allowing me to do a technical sharing to the fraternity of offshore and floater community. Today, my technical sharing paper is Marine Design Integrity for Offshore Floating Structures Post-Tropical Storm PABUK. This paper, this is not a first paper. This paper has been presented previously in OTC last year. So today is for and also have the opportunity to share to the other groups such as Rina MRS on this paper. So the presentation focuses on the integrity of marine design for offshore floating structures in the aftermath of tropical storm PABUK. It will highlight on the significant impacts on the storm and the critical assessment conducted to ensure the reliability and safety of floating offshore facility. Okay, so the today outline will be on the outlines the presentation structures, including the background, objective, methodology, evaluations, results, and conclusion. On this background, so this tropical storm started or maybe happened on the first day of January in the year of 2019. So this tropical storm, identified as PABUK, was developed in South China Sea. Let me put on this. Okay, okay. So it developed in the South China Sea and passes through Peninsular Malaysia before crossing to the southern Thailand and then dissipate in the Andaman Sea. PABUK is a rare case when it started as a tropical depression within the Malaysia water, and then it intensified into the tropical storm in the very short period of time. During this journey, the PABUK path crosses a number of offshore facilities, fixed and floating assets, while it is relatively weaker tail crosses through some of the other assets as well. So the chronological event of this on the 31st December, then the tropical storm depression formed in the middle of this South China Sea, and then it strengthened with the differences of pressure and then intensify with the wind velocity, and then tropical storm PABUK formed, and then it traverse from this the Philippines towards this South China Sea, and then towards the southern of Thailand. This tropical storm PABUK, it weakens, it estimated at about 400 years return period, extreme event at our locations, which means that at the Peninsular Malaysia's offshore, the recorded maximum wave height exceeds all previous recorded measurements. For example, location at PABUK offshore with a H max of 7.7 meter, Dulang 10.5 meters, and the Razak 9.2. All these are way exceeded the previous recorded measurements of wave. And here it shows the visual observation of the wave height in relation to the deck level of the floater. So these photos are taken from the floaters at this point, and then showing that you can see there's a wave kind of here approaching the platforms, and then once it's and then it leave kind of like touches almost reaching to the deck level at about 1.2 meter difference between the deck level and the highest wave crest. That shows how great the wave have been happened during at the point of time. So the objective of these studies is to perform the storm situation assessment on the affected floater during the passing of tropical storm PABUK, and The next, we will do the sensitivity evaluation on the mooring station keeping through this analysis on the storm criteria for floater by establishing the threshold limits. On the storm that impacting, what do we normally do when the storms impact to floaters, and then how does it impact it? So when storm happens, we would like to avoid on these green water loads hitting and or putting pressure on the floaters. And then the consequence of it is if the load is too great, and then the marine lines will be parted or snapped, or can consider broken or snap, loss of marine lines. Because if there's a green water loads hitting on the deck, then it will affect the motion and the stability of the floater. And then with the result of wave slamming on the hull, and then it also will affect the global hull strength. And then so lastly will be the top side. If there's no sufficient air gap between the on the deck, with the wave, with the green waters hitting the floater, and then it will damages all these topside processing facilities. Whereas on the marine lines, floater with the loss of broken marine lines, we will consider it as a damage case condition. Floater will have more motions, and she will has a loss of ability to maintain her station keep. And then it will have a large escalation impact to the riser, and also if the floater position too close to the floater, and then probably it will have a lesser clearance between the floater and the platform. So normally in the engineering practice, the floater it will always be designed with the low combination of ocean criteria for 100 years extreme return period for first stability, for the cases like stability on the intact case, and then damage case with one compartment tank flooding. And then global house longitudinal strength will be still water, bending moment, and shear force. On the mooring station keeping, it will analyze with the intact case and then the damage case with one line failure. And in some project, if the area or location has a much adverse weather condition, they will also probably look into second line mostly loaded. So the applicable codes and standards for the storm, there are various code and standards that we can be applied, such as API RP2SK, American Petroleum Institution, for the recommended practice of two station keeping, with the title of Design and Analysis of Station Keeping System for Floating Structures. API RP2FPS, ISO. For example, another would be the class rules. For example, like ABS, DNV, with the various standards of criteria, technical criteria that can be looked at. For example, like API IP2SK, tension limit and safety factor for intact and damaged cases. API RP2FPS, the abnormal or accidental limit state they will prescribe for the 10,000 years return period, especially for the floater that is deployed in the cyclonic or hurricane prone locations such as the Gulf of Mexico. ISO code standard will be available storm criteria assessment with a safety factor of 1. And then the ABS class rules will be extreme events for 100, 110, and 1 years, for various kind of application. Here is the storm assessment for floater. We did a situational kind of assessment, and then we during that point of time, we only picked the one that is essential to advise on the what will be the best way forward for the floater during the passing of this tropical storm. So we assess a few. There are areas that we consider, such as the mooring station keeping on the intact case, green water effect, freeboard, air gap, mooring station keeping damage case with one line failure, and also second line mostly loaded, structural reliability assessment, stability, and etc. So we identify what the criteria that we can establish. Currently, in service floaters in Malaysia water, they are also proposed on this accidental limit state between 100 to 1,000 years. When we simulate, we also iterate with some sensitivity load cases. And a green water effect, we will evaluate on this sufficient air gap on top side due to this rolling effect and execution movement. And for the mooring case, for the damage case, this case when we run due to the as the overall mooring system has lower stiffness and will eventually produce a lower storm limit. Meaning to say, we do not want, because currently the floater is in operation, we do not want to have it to be, and also the floater itself has a nearby closely located with this fixed platform, which we do not want it to anticipate to be damaged, to broken, and the rest of others criteria. So we place the essential one will be, and we test to the what will be the limit or threshold limit for the mooring lines for the intake, especially on the intake case, and then also the green water. Yeah. So the floater design environmental, this is model using the Flex. It will be model, and then the wave directions as per the diagram will be collinear with the wind and current at with respect to the wave directionality of 45 degrees. So the motion data pre and post PABUK. This is the actual kind of a measurement taken from the nearby field, and then the recorded Hmax around 9 at the previously there was the highest measurement taken was about 10.5, and then the corresponding the HS should be around probably around 6 or 6.5 to 7 significant wave height. And then this is the original measurement data that we use for the during the design during the engineering phase that we adopted, which with the HS of 4.7 at the 100-year return period. So we look back at the previous design data to collect all those the essential parameters of the mooring specification. We need to know that to take the data of the diameter of the diameter of the chain, which is around 105. The type will be the starless chain, grade R4 and R3. And then we to find out this minimum breaking load of 101. Sorry, this is the in the sorry, this is not in the metric ton. This will be in the kilonewton. So, and the referring to the note on the 2 and 3, we will use the lower bound of the minimum breaking load after 10 years of wastage without this corrosion allowance, because the floater has been in operation for and then we will take the most stringent criteria by totally take into account the wastage with the with corrosion that is that perceive that the corrosion has taken place to some of the chain. So we will take the minimum strength of this ring chain. Post analysis, there are 3 areas. First is at the beam, the true beams with the wave that from HS of 9 meters until significant height of 5 meters, it does not pass even the accidental limit state of with a safety of 1. So with that, we disregard because this is due to the large area of the prevailing directions, and then this we can omit it because chances of true beam, because spread mooring configuration with the station according to the prevailing directionality. True beam, we anticipate that a true beam may be always the worst case scenario for such station keeping. Hence, we go to the next one with the directionality. So the floater can withstand until HS of 7 meter after utilizing all those safety margin of the mooring line. So which means that the mooring chain is being stretched until to the limit before it snaps. So you can only withstand until HS of 7 meter. In terms of rolling motions, we also check. So at all cases, it's still within the stability criteria of having the rolling. The maximum roll is at 33 meter. So it's still stable because it's been held down by the mooring lines. So the rolling effect is not as much compared to with a floater that is free from the mooring lines. So it's definitely, it will meet the stability criteria for this. And for the detailed excursions offset at the HS of 7 meters, it marginally cross. The excursion limit is at 45 meter. So it marginally did not pass the excursion limit of 40. The reason we put here 40 is the stretch is because we like to safeguard the risers that is been attached to this floater. So, and with this case, is at the boundary. So, and then hence we establish the excursion threshold limit. So there will be a traffic red lights for the floaters decision to be made when the so from the past analysis, so we put the HS at the 6 meter significant wave height. So the floater will be remain during the operation. The floater will be remain on high alert. And then this is only applicable for wave. Let's say the wave directionality from the is from directionality. It's not the true beam. So, and then the design case we established show by referring to the design book is about 4.7. We make it a 5 meter. Okay. And then at the amber, to red will be 8 meters, and then red alert will be 9. So we anticipate will be the multiple scenarios of multiple lines of failure for that. So in these conclusions, the revised ocean criteria of HMAX was established based on the actual measured data obtained from during the tropical storm PABUK. So the data was collected to be found 6% to 40% higher than the previous ocean criteria. As such, we carry out this sensitivity check to ensure that this mooring strength is sufficient and also within the threshold limit for both anchors and the ferret. So we also provide all necessary precaution and mitigation should the extreme condition approach the amber and red criteria. And in this revised HMAX for the 100 years to 9.7 meter of wave height, the floater will be in the between green and amber zone, which is acceptable, so long that the mooring line will not cause any failure to mooring line, especially from the impact from the both bow and stern. There'll be reaching my last slide. There'll be all. Thank you so much. So I'd like to open this my presentation to the floor for any questions and answer.
Hi, yeah. I just wanted to ask, what was the main objective of the study on mooring design integrity for PABUK?
Sorry. Oh, hi Sabrina. Oh, thank you for your question. The main objective was to evaluate the mooring design integrity and also to establish the threshold limit as I presented for this operational floater unit that experiencing significant force during the storm. So whether the assessment was done to check whether there's sufficient strength before the mooring line started to be parted, and also to also give some establish what will be the mitigation should that happen. So that's why we established the traffic light for the various wave category, and the operation team can have can be stay alert, and then be action can so that action can be taken by the operation team.
I see.
Hello,
We
Engineer
have one
Rosie.
question.
Hello. Thank you, Wenji, as usual. Group presentation. Wenji, my question is more towards I think you mentioned about 100-year storm kind of design, right, for the mooring line. I think looking at the current trend, client will be more request to get cheaper solution. Whether we can drop this 100-year storm to maybe 50-year storm. Have you had a thought on this subject? I mean, making the design more, I would say, cost savvy, however, still within the safety margin that we have. Thank you.
Okay, thank you, Jerosi. I think this is going to be a tough question to answer. We technically per se, we probably there's a room for improvement on these 100 years. But should anything happens, like for example, let's say something like rare event such as a PABUK that came passing by, if we drop the, I mean, if we reduce the so-called extreme condition from 100 to 50 years, and then we'll be on the tiptoe kind of line. What going to be safeguards our floaters at offshore then? Unless there have been certain risk assessment can be taken place, we can probably look into to reduce from 100 years to 50 years. I know that on the offshore renewables, they are, because it's kind of like unmanned kind of floaters, they also has reduced. I mean, the marine lines has been evaluated for 15 years return period for that. Whereas our floaters that carry hydrocarbons, and then there's also some minimum, some consideration for manning. Dropping to 50, from 100 to 50, probably we have to assess with some level of risk assessment for it to be acceptable then.
Okay, noted risk assessment and also how to safeguard in the event of emergency. Thank you, William. Yeah.
Mr. Lim Yu Yao, raise your hand.
Hello. Hi. Hi, my name is Lim Yu Yao.
Hello,
Yeah,
Mr.
so
Lim.
yes, thank you for the good presentation. I just want to ask, after the PABUK storm passed the FSO SEPAT, was there like any like big movement, or it did not stay on the excursion area, or is it just business as usual? Is the mooring line and etc. is strong enough to keep it in location? Yeah, just a question. Not sure if you can answer it, but yeah, thank you.
So during the passing of this PABUK, we also check with the operation team, and then they give us some feedback. And I mean, eventually post PABUK, there will be all those inspection and surveillance need to be carried out to assess on the what damage has occurred or not. So thankfully, or maybe it's nothing damage has been cited on the FSO. But so the mooring lines are still intact. There's none of the lines are was broken. And with the assessment done, I think you see the limitation of the mooring lines can survive up to, let's see, maybe HS under 7, and then the recorded data, I think HS was around 6, around there. So maybe it's just pushing when the actual event that took place, the mooring lines was probably at this on the upper bound limit. So nothing, yeah. So probably nothing was impacted. Definitely there will be some movement. So I think we're not sure unless there's some recorded kind of GPS to establish the movement. So we don't have that kind of sensor. Yeah. Thanks.
Okay, thank you very much, Wenjie. Thank you.
Wendy, we have one question from the chat from Mr. Charles Lim asking about what is the assumed reasoning for change in the metocean criteria.
What's the reasoning of a change of metocean criteria? Okay, so metocean analysis is always based on statistical value, right? So with the passing by of this is considered a data. So all the hindcast data will be need to re-evaluated to reflect whether this set of data still deemed usable, or they have to be kind of recalculate again to establish a new metocean data for the future project. So that's where there's the revision came in. Once because all these have to be updated, right? So with the right measurements data that we have, so we can have a better understanding of the environment, and then we can design all the future floater with the right set of ocean the hindcast data for to predict in the next 100 years for all these operational floaters, it can survive all these kind of once-off events kind of thing. Yeah.
Okay, thank you. When you perhaps last question, I also have question.
Mm-hmm.
Uh, First, why PABUK storm? Why not other storm? Okay, that's number one. And then number two, based on the study, found out that uh, uh, two lines exceed 7 meter, right? So,
Mm-hmm.
so what should we do? How should we react? Should we change oh, I don't know. So what is the way forward based on that finding? Perhaps you can share the thoughts there.
I think okay. So I think statistically, uh, okay, there was took out that so in the past from now until I think there was a range of data of a so-called rare case of a storm data. Uh, 2019 happened once, which is registered this PABUK event of estimated at around 400 return period, 400-year return period. So it's kind of very rare case. So in the past years, there's no we don't hear such kind of uh, tropical storm passing by this peninsula vessel crossing towards the Thailand. Uh, we have always noted there's a cyclonic happen around on the upper zone, around the Vietnam areas, which is very frequent cyclonic, and also some area around this Philippines and Sabah. Very rare case is kind of like passing by here. So that's one. Uh, on the second question on the how do we react if if wait, no, sorry, when the HS 7 or 8 9, this is the okay. So on the 8, we're probably expecting the one line will be filled at the anchors, so maybe exceeding the anchor holding capacity as well. So uh, operationally, when when there's a notifications of tropical storm building up in the area, there will probably kind of like emergency kind of alert for maybe non-mariners to kind of like I think abandon the floaters, evacuate, more like evacuation. So evacuating, and then on the uh, on the essential marine teams that have been staying on board with the captain. So probably they will take charge of the command and then looking at this uh, the areas, the situation at the point of time. Yeah, and I that will be one. And then let's say should there's be uh, uh, and then the flow lines had to be shut in so that to stop production from the producing platform, so that we can safeguard of all these to prevent the to prevent the escalation of LPC. And yeah, I think that's few things we can have it on the operational kind of mitigations plans for each for the category.
Mhm. Okay, thank you very much, Angie. Okay, I believe there are more questions that the audience want to ask, but in the interest of time, If let's say you have any other question, you may post it in the chat, and perhaps our Tomenji can respond that later. But now let's go into the second topic. But before that, please give a round of applause to IR Tomenji for his great sharing.
Thank you so much, guys. Thank you.
Thank you. Okay, so we will go to the second topic. Our presenter is Mr. Charles Lim, and he will talk about the topic uh, floating solution, the Singapore perspective. But before that, let me briefly describe Mr. Charles' career background as well as his education. Mr. Charles is a maritime enthusiast with extensive experience in business development and project management, specializing in infrastructure industry supporting oil and gas, logistics, power generation, including renewable, hospitality, and agri-aquaculture sectors. So currently, he engaged with European independent power producer, driving the development of power project and data centers across the region. Co-founder of the Society of Floating Solutions Singapore, where he served as the vice president and honorary secretary. Uh, Talking about Mr. Charles Lim education, he has a Bachelor of Engineering from Monash University, Master of Project Management from the University of Adelaide, and he also have a project management professional certification. He's a certified PMP. Okay, so without further ado, I would like to welcome Mr. Charles Lim to share his uh, topic on floating solution, the Singapore perspective. Welcome, Mr. Charles Lim.
Thanks, Encik Aslan. Can you hear me?
Yes.
Okay, give me a second. I'm just going to share my screen. Let me know if you're able to see my slides.
Okay, we can see.
Okay, thank you very much. Very interesting topic from the first speaker, IR Tong. That brought back memories. I used to sell mooring line integrity monitoring systems with a company called BMT. So that was many years back. But now I'm in a different industry, but still very much in touch with the maritime industry. So special thanks to the joint branch of RINAR and IMRS, especially IR Shankar Jonathan, and as well as Miss Nur Sabrina and Encik Aslan for organizing today's session, and as well as to all the participants here today on this Monday evening. So often for events like these, I usually represent my society, the Society of Floating Solutions in Singapore. It's founded in 2017 to promote the adoption of floating structures for various applications, especially novel ones. So if you're asking like what, then please stay on and listen to my session. So the society, among other things, we are also the joint organizers of the World Conference on Floating Solutions series. So we had a couple of conferences over the years, started in Singapore, then I think we moved to Netherlands, Japan. Last year it was in Hong Kong, and this year it'll be in Finland. So if you do have interest, yeah, please you can do a quick Google search and get more info from there. So before I start my session, a bit of a disclaimer. So all photos and images used here are the property of its original owner. And today will be less of a technical talk, but more of a storytelling from my side on the opportunities and probably possibilities that are available to Singapore and Malaysia by the adoption of floating solutions or floating structures. So for those of you from the oil and gas industry, I think you should be familiar with some of the brand names here. Singapore, being a maritime country, have a very robust shipbuilding industry, supporting the country's core, which is into trading, finance, and legal. So if we talk about floating solutions, I think we probably could separate it into two main categories. One, which is things that move or mobile. So things that I think most of us are familiar with, vessels, utility vessels such as tugboats, fireboats, supply vessels. And on the industrial or commercial side of things, you have dry bulk carriers, liquid bulk, container vessels, and recently gas carriers as well. Very seldom we see recreational vessels being built in Singapore, like your luxury yacht, and definitely Singapore do not build fishing boats. Whereas on the static side, I think you can see floating structures such as offshore wind substation being fabricated recently, high-tech fish farms, and also floating structures that are somewhere in between the spectrum. So things like FPSOs, FSOs, FSRUs, FLNG, no, but you never know. And probably we'll see more construction and accommodation budgets soon, especially for the offshore wind side of things. So shipyards here, we can segregate them into a few main categories. The big oil and gas ones, looking at FPSO, FSO conversions, the yards that supporting the oil and gas side, but focusing more on marine support vessels such as your OSVs. And they also do even smaller vessels such as your fireboat, petrol boat, ferries, tugboat, and crew transfer vessels. Singapore also do have a very matured marine defense industry, where they often build their own naval vessels. So naval vessels of 3,000 tons and below are often built in country. Yeah, so that's frigate size and below, if you are familiar. So Singapore do not fabricate or do not construct what we term as chippy vessels. So your container vessels, your bulk carrier, all that goes to China, Japan, Korea, as we all know, and definitely no cruise vessels as well. So to touch a bit on what's currently happening in Singapore. So I believe the maritime industry is going through a transition, mainly driven by the cyclical nature of the oil and gas market. Many of the shipyards, especially those that are serving the oil and gas industry, was hit badly when oil price hit the $30 per barrel and below. So many went bust, some undergo consolidation, but yeah, those have survived now, are looking at backup plans, exploring what they can do when the market is not so good on the oil and gas side. Although a few of them has made declaration that they are looking to exit the oil and gas market, but we do not see that happening anytime soon. So it is a transition. So you'll see hybrid technologies being adopted. So not purely green, but maybe on the blue side. Yeah, especially in offshore wind and nearshore solar. So what are some of the vessels that are in this energy, or rather involved in this energy transition. I think one of the major ones that we can see is those that are involved with natural gas, LNG vessels, such as FSRUs, FSUs, LNG to power barges, and gas carriers. On the shipping side, we do see more vessels adopting hybrid propulsion, so a mix of probably LNG, probably blended with hydrogen, or that's what they say, or rather hydrogen ready, but we don't see wide adoption at the moment. And on the slightly smaller side, on the coastal side, I think due to regulatory requirements, we see coastal vessels now adopting what we call electric propulsion. As you can see here on the screen, Yinsen, I believe, is a Malaysian company that heavily involved. On the top right, that's their hydro mover. So that's an electric cargo transport vessel. And on the bottom is their hydro glider, which is an electric hydrofoil design crew transfer vessel, which I believe mainly would be for the offshore wind market. To touch a bit on something that is slightly Singapore, as you can see here on the screen, this is the border map of Singapore. Singapore has around 730 kilometers square of land and 600 kilometers square of sea space. So it's almost the same, even after taking into account of reclamation. And often people say Singapore's biggest problem is there's no water, right? But it's not right? Because now with desalination plants, you have power, you have water, right? And then when people say, Singapore have no power, right? But that you can easily import, right? Either through transmission line or through the importation of fuel. And that's power is being generated in country. To me, the biggest problem is land, yeah. And Singapore has been reclaiming land for as long as I can recall. And now Singapore is under the UN list, or rather being blacklisted for sand importation. So I believe one of the uh, most probable solution to solve Singapore's land problem is to adopt floating structures. Yeah. So imagine this. Build up space in Singapore typically costs between 400 to 3,000 Sing dollars per square feet, as compared to Malaysia, which I think in Bukit Bintang area or KLCC area, the most expensive condo would probably only cost around 3,000 ringgit per square feet. Yeah, and to compare it with the cost of a floating structure, that's around probably 300 Singapore dollar per square feet. So that makes total economic sense to actually consider floating structures as compared to reclaiming land and building buildings on top. So a bit on the border towards the east, you can see a slight bulge. That's due to the disputed Petra Branca or Pulau Batu Putih that Singapore got awarded. Towards the west side, that is the Tuas Megaport. Land has been reclaimed all the way to the Malaysian border. And towards the south is the Southern Islands, which borders Batam and Bintan Island of Indonesia. So yeah, not much space available, but if the government could fully utilize it, then it will definitely make more economic sense. So sea space planning is currently now under the Urban Redevelopment Authority of Singapore, or also known as URA, while most of the regulations falls under, or the main regulator falls under the Maritime and Port Authority of Singapore, MPA. However, just from the name, their focus is mainly in the port space and also shipping. So you have large swath of sea space being designated as anchorage area. So that's where vessels fuel to berth at the port, and this actually do not bring around much economic activity. And this can be seen if you are at the beach or in flight towards Changi Airport. Thousands of vessels just waiting there. Not only is it being an eyesore, but actually more can be done at this space. So what are some of the novel floating structures that we can see in Singapore? If you look at the two photos at the top, on the top left, that's a floating accommodation barge by DB Maritime, and on the top right, towards the back, is Flotel by Keppel. So both were brought in during the COVID period to isolate foreign workers. So we have tried, the society has tried many times to convince the government that floating structures is something viable for Singapore, but we have been receiving a lot of pushbacks. But during COVID, the government saw the usefulness of such a concept. Towards the bottom, on the center and the left, those are Eco Spark and Blue Currents high-tech floating fish farms. And I think a very interesting one is the one on the bottom right. That's Hotel He Gung Gang, initially constructed in Singapore and towed to the Great Barrier Reef in Australia, also known as the Four Seasons at the Great Barrier Reef in 1988. But due to bad weather and also its remote location, the business went bust, right? And it was eventually sold to Seoul and towed to Ho Chi Minh City for officers of the U.S. Army during the R&R during the time of the Vietnam War. And it was a big success, And of course, as we all know, the Vietnam War ended, and the business case for it went off as well. So Hyundai purchased this hotel and have it shipped to North Korea to promote friendship tourism and also meeting of family members between the North and South Koreans. It was opened in 2000 till 2008. However, due to ongoing conflicts, that program has shut down, and it was remained there till 2020. And under the orders of President Kim, it was decommissioned. So, what are the ones? The other floating solutions or structures that you can see now in Singapore. Towards the left, that's a floating swimming pool at the very exquisite condo development called the Reef at King's Dock. If you were to head to Sentosa Island, you can actually have a look. This is located next to the shopping mall called Vivo City. Towards the bottom, that's a floating water park with its bouncy castles, and this is located at the waters of Sentosa. It's known as Hydro Dash, but I think since been taken down, if I'm not mistaken, last year or so. And towards the top is a floating restaurant, and slightly behind the restaurant is a fish farm. So if you are a avid paddler, kayaker, or dragon boater in Singapore, you most likely recognize this place, because you can, do your activities and stop there to have a meal once you're tired. So these are some of the novel solutions that we are seeing, and the one that excites me the most, and I think especially for an engineer, is this that is being proposed by Keppel Corporation. And if you are someone that has been following the data center market, this actually solves a lot of the problems that the data center market faces there. So this is an integrated energy and data center park where you have floating LNG to power, floating data center, floating BESS, that's battery energy storage system, and floating desalination plant, located all within the same vicinity. Yeah. So by integrating power, you could actually valorize waste coal energy or heat into productive power. Yeah, so that will help increase efficiency, prevent losses, and if you are familiar with RECs, that's renewable energy certificates, or even carbon credits. This particular project will actually allow you to generate the energy efficiency certificates. Yeah. Currently, it's not a thing in Singapore or even in Malaysia, I believe, but yeah, this project would probably push the government to look at it as a possibility. So why floating? So imagine if you were to put this on land and it gets decommissioned after a couple of years, you probably got to get everything destroyed, yeah, brought down. But being floating, you can actually easily tow it away and sell it off to another country that might benefit from it. So yeah, less losses. Uh, and what are some of the future possibilities? Even for Malaysia, is probably a floating nuclear power plant. Yeah, so Singapore has been thinking about this for many years, nuclear in general, but not just floating. And I think Malaysia in the news has recently also brought this up. What we see on screen here is academic. It's a floating nuclear power plant made up of two 35 megawatt reactor, yeah, powering the town of PABUK in northern Russia. So the reactor, with its size, is deemed as a small modular reactor, and we'll probably see a wide adoption of such solutions soon. Uh, when it was mentioned a couple of years back, the identified location was Natuna, a bunch of small little islands between Peninsula Malaysia and Borneo, which is administered by Indonesia. But having gone through the first speaker's topic just now, probably is not a very good location. Yeah. So why Natuna in the first place? Because we believe by having such a power plant, it would probably alert every country around the power plant. So by having it as a joint project, probably between Singapore, Malaysia, and Indonesia, that way everyone would put in effort to actually make it a success. Yeah, and all three countries would actually be able to benefit from it. Uh, what are some of the more crazy ideas? There are many concepts on floating, floating metropolis, floating cities, and what you see on screen here are some of the few examples. So on the top left and on top center, that's Green Float 1 by Shimizu Corporation of Japan. So it's meant to be a 1,000 meters high structure with a 3 kilometer wide diameter. Yeah, so to them, these actually would help solve Singapore's problem. But what they did not know is that the structure will require 100 to 200-meter draft, which Singapore do not have. Yeah, Singapore is shallow water, or at most along the shipping lines is 20 or 30 meters. Yeah, if I'm not wrong. So because of that, they proposed a new concept, which is on the top right. So that's Green Float 2. They had discussions with EDB, Economic Development Board of Singapore. That's like MIDA in Malaysia. And apparently they had received in principle approval in 2023. But whether it will really turn into reality, we don't know. Yeah. On the bottom left, that's a concept by Vincent Calabot. He's a very renowned architect. That concept is known as a lily pad. So architects, they like to draw very how to interesting concepts, but as engineers often we know it's not easy. Uh, the one at the bottom center, that's Oceanics. It's a concept endorsed by the UN to be developed in Korea as a test-bed city. Yeah, for a floating city to solve many of the modern day problems, and that's including climate change. I've not received any updates since this announcement, but hopefully, yeah, we shall see some progress soon. And out of all these concepts, the one that really took place is Sibit Islands, or Sibit, depending on who you speak to in Korea. So these three islands on the bottom right is already up since 2014. With all the K-pop going on, if your family decides to visit Korea, or in particular Seoul, do drop by. It was constructed at a cost of 300 million. It hosts a convention hall, performance hall, commercial space such as restaurants, cafes, centers for water leisure activities, and so on and so forth. Yeah, I think it's worth a visit if you happen to be in Seoul. Mindful of time, I'll move a little faster. On the materials side, I think a lot of us here, we are familiar with steel being the main material for either vessels or oil rigs, but uh, the society would like to also promote concrete as a floating material for structures instead of steel. It is more durable, more economical in the long run. And although it's heavier, it offers better stability, better weather resistance with a longer design life. And unlike steel-based structures, class would require less periodic inspections. Yeah. So for vessel, typically you have 30 years, then maybe you can do a bit of extension, another 20 years, 5 years inspection in between. Sometimes it's biannually. Whereas concrete, you can just leave it there for 100 years, you'll still be there, no problem. Yeah, a lot of questions, a lot of people like to ask, can concrete float? Yes, the answer is yes. It all depends on Archimedes principle, right? Buoyancy. Yeah, and concrete being heavy works best as the base foundation or the hull. Yeah, it lowers the center, while the top side or superstructure can be made with lighter materials. So on screen here at the bottom left, that's a preview. I don't want to pretend I know how to pronounce. So that's a floating dock designed by GLEC Engineering in Singapore. It was fabricated in Batam and lifted to Hawaii. Yeah. The wing walls are made from aluminium, but the base hull is made of floating concrete. So these are some of the examples that we can see. And in addition to the hull material, for floating structures also, when it comes to concrete, you often involve the rebar. Yeah. I think common knowledge, or rather conventional construction methodology is to use steel rebar, but steel, as you know, corrodes easily, and if concrete being on water, you still do have ions or chloride ions, going in and causing corrosion on the inside. Yeah. So instead of that, we are trying to promote the use of basalt or fiberglass rebars for floating solutions. So what is basalt? Basalt is basically volcanic rock being heated, trapped, and coated with resin. Yeah. So it's tougher. It has a higher tensile strength than steel. It's corrosion resistant. It can withstand alkalic or acidic kind of environment, and it does not release toxic fumes, yeah, when exposed to high temperature like wood, or change its properties like steel. It's lighter than steel, less energy intensive to produce. So for countries where there is carbon tax, I think there's benefit in considering this. Yeah. Yeah, and so after today's session, what can we take away from my session? Yeah, so Malaysia is not new to floating solutions. There are many. Yeah, if you have been keeping your eye open, towards the left, there's a floating ferry terminal in Kenyir, Tasik Kenyir, and Pahang. And towards the center and the right, there's a floating restaurant, unfortunately swept away, I think recently, last year only, located at Kota Baru. So I think the key to uh, adopting floating solutions is probably to do it with sound engineering and scientific approach, not just the design, but the fabrication and installation as well. Just like how we approach getting a ship or building up. Yeah. Um, so is there a future for floating solutions for Malaysia? I would say yes, but probably it would initially start towards functional infrastructure. So like things like power plants, your ports, yeah, infrastructure of those kind. And when the price of real estate hits parity, as compared to fabrication cost of floating structure, then you'll see more novel solutions. So I believe probably uh, Penang and Malacca would stand to benefit from that. And on that note, I probably would end my sharing for now and move into Q&A.
Hi, Mr. Charles. Sabrina here. Just a quick question in terms of what are some of the challenges that can come about adopting this floating solution?
I think at the moment there is no clear or matured regulatory framework to allow such floating solutions. If we are referring to the oil and gas industry, yes, but if we are talking about novel floating solutions, no. And without proper knowledge of the risk, uh, you won't be able to insure such projects, yeah, and without insurance it becomes not bankable. So not being able to get financing is a big issue for any project. And often floating structures is deemed as a depreciating asset. Yeah. So imagine if you buy a house and the price of the house goes down, that's not something you want. And I think the key is probably to have a change in the people's mindset. Yeah, I mean we are used to living on land. Um, the Dutch have been living on water for a long time, but yeah, that's only them. But I think with a change in mindset, yeah, that would help probably solve a lot of the challenges that we see.
I see. Thank you. Uh, is there any more questions from the floor?
Hello, Charles. Rosby here. You mentioned about carbon credits and also REC. I want to know more about RECs. I think Singapore is quite familiar. I think how they implement and how this benefit to the industry who sort of implement the floating structure kind of solution.
So Rex, there's probably two markets for it. One is voluntary, one is mandatory. Yeah, mandatory means it's regulated. So for a country like Singapore, if you are a high carbon emission emitter, you are being taxed. Yeah, so there's a carbon tax. Yeah, so uh, either you pay the carbon tax or you can knock it off with either carbon credit, which does not exist in Singapore, and the closest one would be Rex, yeah, if you are a high consumer of power. So by comparing a project which is on land and on water you are able to do or you are able to run your operations more efficiently. Uh, that way you actually emit or rather have a smaller carbon footprint, and Rex can help you up to a certain extent, but yeah, by emitting less, by having a smaller carbon footprint, you actually you are more environmental friendly, I would say. And on the Rex side, Rex production, we see adoption of floating solar farms in Singapore. Although there's not much land, but yeah, the country is trying to do its best. For Malaysia, Rex is not a big thing yet, but on the voluntary market side, we do see a lot of adoption, especially by MNCs that are looking to export to the European market. They need to show that they have a small carbon footprint, and I guess that's where Rex help. I hope that answers your your question.
Excellent, excellent. I think in your example, you put a comparison between on land and on water, right? And what I can really digest from there, if you were to do it on water, you can, you can get more racks. You can claim more racks. Is it correct? By deploying a smaller footprint. Is it correct?
Ah, okay. I think you are referring to the energy efficiency certificate. So that's not Rex. So that's
Okay.
a group of certificates. So like for example, uh in European countries, so this concept started there. If you have a building which runs on fluorescent bulbs, right? And then you
Mm-hmm.
decide to change to LED bulbs, and you can justify the decrease in carbon emission. They will award you a certificate.
Oh, okay. They will
Yeah.
award you a certificate. I
Yeah. So,
see.
like for example, I think 40% of Malaysia's power is generated by coal, right?
Hmm?
If Malaysia decides to retire those coal power plants prematurely and probably adopt either renewables or maybe LNG, then Malaysia will be able to generate these energy efficiency certificates.
Mm.
Yeah.
Thank you. Thank you.
Yeah.
Okay.
Right.
Thank you, Mr. Charles. In the interest of time, I, if there is any further question, perhaps you can post it in the chat, or if let's say you can make it here, perhaps you can email to Mr. Charles or IR Tong Wenji. Yeah? Mr. Charles, if okay, you can put your email address here so that people can email to you for reference, if any. Same goes to IR Tong Wenji, yeah, if you don't mind. Uh, so again, thank you very much, Charles, for very insightful presentation, talking about floating solution, a Singapore perspective. It is a very and eye-opening to me as well, because there are a lot of novel solutions there that perhaps we can even replicate in Malaysia and some other countries as well. Okay, so uh, uh, I would like all of us to give a round of applause to both our speakers here, IR Tong Wenji and Mr. Charles Lim, for their great presentation. Okay, thanks. So before we end our session and before I share our QR code for the certificate of attendance, perhaps we can have a photo session. It would be great if each and every one of us can open your camera for us to take a photo.
It's dark already at Tower 3. But I have my light.
Okay. Okay. How about the rest? Sabrina, perhaps we can unshare the slide first and then, yeah.
The speaker
Yeah.
is important. The two speaker is important.
All right. So I'll just take a quick snapshot. All right. Okay. Just one more. Okay, that's perfect.
Thank you.
Okay. Okay. With that, thank you very much all, and we'll see again in next tech talk session, which will be in February. So with that, Sabrina, perhaps you can share the QR code for others to scan.
Yep.
So you can scan this QR code, fill up your email address, and perhaps if there is any feedback on this event, please put your feedback in that form as well. The certificate will be issued in the next few days. Okay, right? So we will leave the scan, the QR code here for the next few minutes, and we will share as well in the chat. Tab. So with that, thanks again to both speaker, Atom Wenji and Mr. Chaplin, for being our honorable speakers today. And thanks also to all the attendees, the audience here, our honorable uh, attendees for our session today. See you again in February for our next Tech Talk session. With that, Assalamualaikum warahmatullah and a very good afternoon. Bye.
Thank you, everyone.
Thank you so much.
Thank
Thank
you.
you.
Bye.
Thank you.
Thank you. Thank you.
Thank you.
Bye bye.
Bye.
Thank you.
You all.